So that works for any layout of devices. I might want to test one 4-pole changeover relay. There's the 8 contacts that requires. Or 8 changeover relays. And you'll notice that the layout generator automatically assigns the colors. You can also configure the input layout generator to change your device prefix from R to K, or to change the order of the normally open and normally open contacts to suit your hardware connection. The stick and miss settings comprise some comparator thresholds for stick and for miss, and settings for the stick and miss monitoring windows. Presently you can see a summary here that shows a 50% duty cycle and start and end percentages for these windows. The windows themselves are configurable by clicking on this button, and you can drag these windows around. You'll see the values changing down the bottom here, or you can assign them fixed values or set them both to a maximum setting. So there's a lot of flexibility here for choosing exactly when the measurement is made. If you have an application where the duty cycle needs to be changed, simply grab this center blue marker and move it around to change it to another duty cycle. You might need to move the windows around a little bit, but that's fine. You can do that. These blue areas show an estimate of when the contacts are closed and stable and open and stable, and this information is taken from those 20 millisecond values that we saw earlier. So this gives us some visual guide as to where the windows are in relation to contact stability. So once that's set, that's programmed our stick and miss windows. And on this stick and miss tab we can specify the coil voltage that will be applied to the coil during stick and miss testing, and whether we want the system to stop on a failure or just to carry on. Operate and release parameters are programmed on this page, and we can specify whether operate and release is to be performed at the start of the test, at the end of every interval, and again at the test end. By choosing the selection in these boxes, you can control how many operate and release tests are actually performed. If you wish, operate and release testing can be done using a different nominal voltage than that for stick and miss. Normally you would use the same value, that's the default here, or uncheck this box and put in a new voltage. These are the operate and release test limits. Any operate voltage outside of the upper pair here will be a failure. Any release voltage outside of this lower pair will be a failure. And the fine detail of the operate and release testing can be configured by editing its properties. Here you can see some additional settings that you can make for the operate and release ramp configuration, although normally you probably won't want to get into this. On the advanced page we've got the ability to make offline failures. This is more for useful demonstration purposes, so again that's something which is probably not a major area of interest. The detailed hardware operation of the system is controlled by what we call a hardware profile. That hardware profile is available by clicking on this page here, and it's also available by choosing Settings, Edit Hardware Profile. The purpose of the hardware profile is to allow certain machine hardware events to occur at strategic test intervals. The test events are listed down the left hand side here, and you will have already been supplied with pre-programmed hardware profiles to suit specific relay types. What happens is that the hardware profile is providing a kind of hardware template that configures the system to suit that particular style of relay. Generally speaking, it's only the style of the relay that needs a different hardware profile. Variations in coil voltage are coped with by just directly setting that in the test. What the hardware profile does do, though, is it provides you with a lot of flexibility for specifying which power supplies you wish to use to provide stick and miss control and operate and release control. Finally, just a look behind the scenes at a few less important but quite useful features. There is a system log file which records all of the information about how the test was performed and when certain events occurred. For example, we can see here that we started a test. If I scroll back here, you can see that we started the software here and started running a test here at this point. And these individual log file entries show you how the test was performed and give you timestamps of various activity, which enables you maybe to fault find an unattended test to see what happened to it. Okay, that is a look at the Reflex40, a simple overview, and how the test is programmed and run.